Hey guys, welcome back to the RCA RR-359 restoration project. After bouncing around in the U.S. postal system for several weeks, this has arrived. This is potential base for a new tuner. By no means is this the be-all, end-all, perfect substitute for the missing tuner. It's just something that I came across looking at gained 3-section tuning caps on eBay, and when I looked up the specs for it, it's actually pretty darn close to the original, and physically it looks to be of similar size. So the original had 3 variable capacitor suctions ganged on a central shaft that ranged from roughly 6 picofarad to 110, something like that. 2 sections were identical, one was slightly lower, I think. But this is in the ballpark, which is fantastic, because we don't have to get perfectly exactly matching the original, because, well, one, we have trimmers in parallel with each of these, which allows us to adjust it a little bit. All of these have splits in them, which you can use to bend and manipulate to alter the characteristics a little bit. I could even pop one of these sections out if I needed to. Also, we don't have to cover the original tuning range. So we'll take a look at the schematic in a bit. I'm going to try to redraw the schematic so it's more legible and we can wrap our heads around how it actually works a little bit better. But basically, the tuner is not a tuner like we would think of in a more modern set. Like typically there's 3 tubes or 2 tubes that have multiple elements. One will be used for an RF front end. Let's use an RCA early tuner, for example. It has 3 6J6s in it. One of them is the RF front end, one of them is the local oscillator, one of them is the mixer. This isn't like that. There is no RF front end, and the mixer's on the main chassis. This is just a local oscillator and a variable bandpass filter, I think, on the front end and the back end. Now, one thing I don't know yet about this set is what is the IF frequency? It sure isn't 44 megahertz, and I'm pretty darn sure it's not 22 megahertz. It's probably something more like 15 megahertz, and it's not going to be as wide as a modern set. One of the consequences of having no RF front end is that the local oscillator basically mixes into the signal coming into the antenna, which means it radiates the local oscillator back out the antenna, which had some amusing consequences when they had 2 or more of these sets in close proximity, like at the World's Fair or some expositions. I was told what they had to do is they had one set that had a functioning tuner, and they disabled the others and used sort of an amplifier and hardwired them all together to avoid that problem. Now, I've also gotten some very helpful comments from some viewers. Several of you have offered to dig through your stash to find one that's suitable. One guy volunteered his services to fabricate parts, and I believe I was given contact info for a place that could perhaps fabricate one for me. That's getting way ahead of ourselves. Let's take a little bit of a step back before I dig into the schematic, in that we don't even have to have a tuner. Worst case, I could directly feed a video signal right to the video amp and forget about the whole IF and the tuner and all that. I'd rather not do that. Or I could feed a signal right into the IF if I built a suitable modulator that could skip that step. Now, as far as some of you have said, well, how are you going to make a signal that's 343 lines as it was originally set up, or 441 as it was later set up? It's entirely possible my set's already been modified to run on 525. But even if it wasn't the 441 modification that was done when it was converted to a 12-inch set, has enough range, it can display a 525 line signal. What I don't know, the big question, is the split between the audio and the video carrier has varied over time. Modern stuff, it's 4.5 megahertz, but back then it was less. I don't know how this has been set up. And then some of you have wondered, well, how are you going to get even if you get this working, what about FM sound? The AM Well, one, that my set may have been tweaked to work better with FM modulated sound. Again, this set was being tinkered on in the 50s. So we'll find out as we dig more into it. I got to sweep the IF. We have to inject some signals once we get the set running and see what happens. But an AM detector back then could get some sound that was FM modulated. It might not be the greatest quality, might not be the best volume, but you would hear something. So anyways, let's take a look back at this. This is nice. This is nice. This has good action. It's not damaged. Having those trimmers there is great because it's just how the original had it. It's a little bit crude, but we can work with this. We got all kinds of terminals here because if you look at the original, as we will in a moment, they mounted all the components directly to this. Primarily those are coils. We don't have any values for any of the coils, but we know what the tuning range is, like 40 to 90 megahertz. So we know what the local oscillator frequency should be. We know what the incoming signal frequency range was. We can do some math. We can figure out, knowing the frequency, knowing the capacitance value, what inductance value do you need to make a bandpass filter, to make a resonance circuit for that frequency. We can figure it out. We're going to do a lot of experimenting. That's why I'm so psyched about this aspect of it, even though I just said it's not strictly necessary, is I think it's going to be fun. I've never built a tuner from scratch before, or even a VFO for that matter, because essentially the bulk of this is just a VFO. And my skills are a little rusty when it comes to this. I looked at the schematic. I still can't quite figure out if it's a Colpitts or a Hartley type oscillator or something else. But I'm hoping some of you out there, or some people on online forums, some guys who are more into homebrew ham stuff, can help me out a little bit to decipher how this circuit works. Just one tube, a 76 tube, forms a local oscillator VFO. You vary the capacitance and varies the frequency of the VFO local oscillator, which mixes with the incoming signal. And the output, you're going to get plus and minus the two frequencies. That's why you need a bandpass filter, so you don't get both coming through. But even if we did, that's the other thing. We don't have multiple broadcast channels. I don't even have to have this variable. I mean, like I said, I have a bunch of options. I'm not going to be tuning in channels 2 through 12 or 1 through 5 like they had back then. I just needed to make it work on one frequency. One last thing about this, while we're experimenting with this, because I said as the mixer's on the main chassis, while we're tinkering with this, or even if I can never get this to work, up on the workbench, I can just use an RF generator to make the local oscillator signal to mix with whatever signal I tried feeding into it. So we have a lot of experimenting, a lot of tests, a lot of trial and error, a lot of R&D we can do to make this thing work. I think it's going to be a real interesting project. Well, thanks to Daryl Hawk, I have a wealth of fantastic photos and some service info. And as he pointed out, I need to make a correction. When I said that the service info is based on or shows my chassis, that's not quite true. What it is a binder of material from this era that includes a bunch of really high quality photographs in addition to the service info. So a photo like this is not part of the service info, it's just a collection of photos that he has. Anyways, here's what an original tuner looks like. So 3-section of variable capacitance, and here's what I'm pretty sure are the trimmer caps. Looks like there are pieces of metal at a bit of an angle, and as you tighten these nuts, it would compress or expand them to change the capacitance, whereas we have little ceramic trimmers, but the same function. And there, of course, there's 76 tube mounted, as I said, right to the capacitor frame, and then we've got various parts. A few dog bones, probably an RF choker too, and then some coils. We can see one here, looks like it's on a phenolic form with a whole bunch of turns. We've got something down there that looks like perhaps a coil or transformer, could be a choke. Can't really tell. So just based on this, it would be tough to come up with something, or just this in the schematic, but sometime in the next couple months, I will visit the Early Television Museum where they have one of these with an original tuner, and I will take as much info, get as much info as I can. As we know, the front of this cabinet opens up easily, so I can get at the tuner without having to pull the chassis out, which I'm not going to do, but we'll get as much info as we can. Here's a look at the front of the set. Now this is a part I would definitely like to 3D print or replicate in some manner. With this, because this has the tuning dial with numbers and the channels on it. The one I have just has a metal disc here where the dial cord would wrap around, but this has a dial scale in here, and then it's got some set screws around it to hold it onto the shaft. But you don't tune it by directly. You didn't put a knob on that shaft. The knob rides on this shaft, which rides along this metal rim here. So a full turn on this just does a portion of this, so you get fine-tuning vernier kind of action there. We can also see a little bit about how it's constructed. Boy, that tube is coming right up, and it's really crammed in there. Of course, I don't have to mount my tube exactly how it was originally, but it'd be nice to get it like on the right side at a similar angle, so that a brief glance it would look like it's the original, at least. All right, finally, schematic time. Now, I have two flavors of the schematic, courtesy of Daryl Hawk. One is the A version, that's what we're looking at, and the other is the B version. Both have some legibility issues. Let's start with the A version. The main legibility problem with this is the lines are a little fat. And if you didn't know anything, I think you'd have a real hard time deciphering some of this. For example, that part. I think that says C64, 30, 36, 38. And then just because I know the type of components this would be using, and I've seen the rest of the schematic, that's going to be an MMF below the number. Microfarad, also known as picofarad, because you can see that all over the place. But if you just had that to look at, I think you'd have a tough time figuring out what it is. Similarly, I think that's 22,000 ohms. Anyways, let's go over this a little bit. So there's our 76 tube. That's our local oscillator. These parallel lines, those are your caps. If they're just two straight lines like that, it's fixed. If you see a line through it or curved with an arrow on one end, those are variable. This is a trimmer. This is part of the rotating ganged cap. And we see this dashed line goes up and over to another one, to another one. Those are our three ganged caps. Up at the top here is our antenna inputs. So antenna inputs go into this network of caps and resistors. There's going to be a bandpass filter, which hooks up into this, which is the mixer tube on the main chassis, and this is our local oscillator. As I say, like all this stuff's on the main chassis. Some of this stuff, or probably all this stuff, and this stuff is on the capacitor frame. Well, I can kind of read the values here. I believe that says 2.5 to 114. This is 8.5 to 115, 8.5 to 115. So I say those three sections are nearly identical. And with our little bit of trimmers, I think I can get what I've got to cover that range, or a good portion of it. We're fine there. This trimmer surprised me. It's a little bit high in value. I think it's 200 to 500. That's a pretty high picofarad range for a little trimmer cap, so I'm curious to see physically what does that look like. Is it multiple plates to get that larger capacitance or large surface area, or they're pushed really close together? Don't know. We'll find out, I hope. But that's about it. So we've got one resistor here. We've got another one here. We've got some fixed capacitors. We can use mica caps for that. That's easy. We've got our variable caps, which counts for most of these parts. So what do we need to figure out? This coupling transformer here, that's going to form a bandpass filter with these two guys. And even if we didn't have that, I mean, we just do wideband and just let everything come in. I mean, we're going to be feeding a signal into this after all. We're not going to be pulling it out of the air. So this whole part isn't exactly essential. We can just feed a signal directly into like this grid and forget about all this stuff. But we'll try to get that working. But this is the important part. This is the local oscillator. So not much to it. So we've got a tube, that's our active element. We've got a resistor here for some biasing, a grid leak, so it's going to ground on one side and over here, so that'll form a negative voltage when current flows through it. This is our power supply. I believe that's the 160 volt bus going through this coil and that coil over to the plate. And then we've got some capacitors and inductors. Pretty sure these two guys are going to set our frequency. Whenever you see a variable capacitor paralleled with an inductor, pretty good odds that sets the frequency, but I believe these also come into play as well. And there's two main types of oscillators, Hartley and Colpitts. Pretty sure this is one of those two. I'm sure one of you knows, or more of you knows which it is and can clue me in. There are also other variations, other types of oscillators, so the name isn't critical, but it would be good to know what circuit this is based off of as we're trying to reproduce it and analyze it. So I've got a pretty good handle on how this works, except for one thing. So as I said, this is our 160 volt positive voltage coming in for the plate supply. We've got a coil here. Now I would think that that's an RF choke, which chokes radio frequencies so it doesn't feed this back into the whole set, because this line goes to all these IF tubes and other circuits. So you don't want that radiating back into the set. But there is no other connection from this circuit to anything else. So how is this local oscillator frequency getting into the mixer to mix to the incoming signal? Now, it could be it's being coupled by one of these guys, because maybe one of these coils is close enough to something else that it's getting through. Or is it coming up through this coil and getting up into here? That's the part I'm not sure about, because I don't know what that part is. So maybe some of you can clue me in on that as well. Yeah, cool, a local oscillator, it's oscillating, but how is it feeding into the mixer? There could be some kind of gimmick. It could just be the way the parts are mounted. It could be a couple wires are close together, like a little gimmick that's feeding the signal in. That's the kind of thing that troubles me a little bit about actually making this work, is knowing. That's where you get into the black art of RF design, is when it's just the proximity of components next to each other that make the circuit work. But we'll do what we can. Now let's take a look at the B version. Main problem with this schematic is we've got, I don't know if that's foxing or what, but there are a lot of these specks throughout it. Could be insect damage or something, I don't know. And we've got some fold lines, and one of them, it probably got rubbed because it looks like it was folded along here. Maybe this got abraded. It rubbed out a lot of these component values, like that resistor there. There's no value there anymore. Well, some of this was identical to the A version, but some of it might not be. But anyways, here's the tuner, which looks to be identical between the two. They both have the A305A experimental tube. Now that's missing from my set at this location, but there is another A305A elsewhere that was replaced, I believe, by a 6D6 in later revisions. So I'm thinking if that's a critical tube, I could take the 305A from my other spot and put it in here and put a 6D6 over there, or vice versa. But right now, yeah, that socket's empty on my set, so that's a little bit of a concern too. But anyways, between the two, I think we can muddle out the values a little bit. So we can see, I'm pretty sure that says 22,000 here. And now we can see it, it says it's 33. So pretty good bet that that's 33 picofarad. And yeah, that trimmer's obliterated. That says 200 to 500. And yeah, otherwise I think it's the same. But again, coils, no component values, so really didn't illuminate anything about how this works. Well, I did a little bit more digging and went through a book I've had for quite a while and flipped through in the past, but that was long before I had one of these pre-war sets, so I glossed over some of the stuff. This is a book simply called Television by Zworkin and Morton, two very prominent figures at RCA. It was published in 1940, and they talk about, well, a lot of the science and the math and the engineering that made television possible and led to the TRK series of televisions, but also the cameras, the control rooms, the transmitters, and all that good stuff. Optics, electron gun design. There's math in here, there's differential equations, there's graphs and charts and all that. A little light on schematics, a little light on details, but as you get towards the back, there is a section on, hey, let's actually make a practical home receiver, and they talk about everything from the aerial down to setting it up and getting good reception and how the TV actually would work in practice. And we get to this, where they talk about the various functional blocks of it, including the tuner. And down here in the corner is a very much simplified schematic of the local oscillator in the tuner that I have. So it sure looks like a Hartley to me, where you've got a single inductor tapped in the middle with a variable capacitor. So, and they're talking about my tuner, as we'll see on the next page. So that is, well, I was going to draw this out, but I think they just saved me the trouble. Down to the bare bones, that is the local oscillator we're going to try to make. So I was pondering, how did they couple the signals between the stages? Well, over here is another very simplified diagram showing the three variable capacitor sections going to the aerial. So that's inductively coupled. And then here is our ganged tuning cap, and these are coils of wire that these are the mystery ones. We don't quite know until I get my hands on one. What's the diameter? What's the gauge of the wire? What's the spacing between the windings? How many turns there are? But they say down here, the three tuned circuits are mutually coupled by the conductance of the common rotor shaft of the tuning condensers. So that's what I was getting at about the kind of the black arts of RF design. We've got three tuned circuits that there is no physical connection between. Just the way they're laid out and physically constructed, that couples the signal between the stages. So we've got our tuned antenna input, we've got our tuned input to the mixer, and we've got our tuned local oscillator. So those are those three ganged capacitors right there. And if we turn the page, hey, there it is. That's what we're trying to make. So, tantalizingly close to giving me everything that I need, but not quite. But at least we get the theory of how it's supposed to work and put together. Here's a look at what I showed in an earlier video, one of the IF stages with the tube mounted directly on top of some coils and components that are inside of a metal can. And they talk about going through the IF stages and all that, and we get a very simplified diagram showing the RF and IF stages. So there again is a very simplified breakdown of the local oscillator, the antenna input. So it's that schematic I showed earlier with no component values down to bare bones and the rest of it. But no complete schematic, but I've got that from other sources, so we're okay there. But last thing I wanted to show you was they do go into some of the other circuits, so as we get into deflection circuits and power supply and stuff. And they do give you this, which, wrong way around, which is close to the, oh no, sorry, this is an actual production model. This is how the TRKs are put together. So they jump right from the experimental model to a production model. Then they talk about making experimental models, and that's something or experimental receivers, I don't think it's something I mentioned, is that RCA wanted TV to be successful, and they encouraged folks to make their own receivers, and from what I've read, they would sell components. And I don't know if they had complete kits or they just sold CRTs and transformers and coils and stuff, but they very much encouraged tinkerers and experimenters to make their own, and here is a complete schematic for an experimental television receiver. Again, no component values or anything, but it's got all the basic elements right there. Oh, hey, whoa. I spoke too fast. They do have the component values over here, but this is not my set. But hey, if anybody's very enterprising, get a copy of this book, and here you go. Build it. L1 to L23 described in text. I don't know about that. Oh, yes they are. Wow. Okay. There you can wind your own coils. Huh. I wonder if anybody did. That's quite an undertaking. All right, so that's going to be it for now. We've got the basics, basic understanding and layout and some components to play around with. So in the not too distant future, I will gather up some more parts. We need a tube socket, we need some enameled wire, we need some of the fixed components, and I'll rig up some power supplies, and we'll play around with this and see if we can get a local oscillator working with this stuff. That's it for now. Thanks for watching.